All right, well, welcome to the webinar today. We're going to be talking about the use of the DPI scanner to go from there through EdgeWise all the way to Revit, and we're going to try to do this all live in this hour of the webinar. In addition, we're going to have a case study in the middle of all of that. So we were just joking before we got online here that we've got 5 different offices involved in this. We're going to be passing data back and forth. We have a number of different connections, so there's all sorts of ways that technology can go bad on this thing. So I'm actually expecting this not to go off without a hitch, but we'll see. It'll be fun regardless. We'll see how this goes. All right, let me just get this slideshow started. So just a real quick agenda. Let you guys know what we're going to be doing here. I'm going to start off with some introductions, so I'll introduce our presenters today, talk a little bit about what we're going to be doing and kind of the goals and context of the presentation today. We're actually going to be doing a live scan. Tom Greaves is going to be up in Boston. Is that right, Tom? Is that where you're located?
I'm in our Boston office, yes.
Boston office. Okay, so he's going to be scanning live. He'll then email that scan directly to Justin, who is one of our application engineers here in the Washington, D.C. area, who will then start the processing inside of EdgeWise. From there, we'll switch off, and we've got presenters with AEI located in San Francisco and then Chapel Hills, North Carolina, so both coasts. They'll be talking about their use of this scanning technology and EdgeWise and creating Revit models. And then finally, we'll switch back to check up on Justin and his modeling progress, watch him model, finish out the model, and export to Revit if all goes well. And during that time period, we'll be taking some Q&A. So should be a lot of fun, but certainly ripe for for all sorts of technical glitches. So we'll hopefully at least most of it will go right. So just to lay the ground rules, all of the participants are going to be muted. There are, and by the way, this is the largest webinar that we've done so far. So obviously there's a lot of interest in this type of a workflow. We had just under 1,000 people registered for this webinar. So obviously we got to keep everybody muted except for the presenters, or it'd be chaos. But we absolutely want to take Q&A, and so as you think of questions, please type them into the chat window in the GoToWebinar session, and we will take those on a first come first serve type of basis. So as you think of questions, go ahead and just type them in, and we'll try to get to as many as we possibly can during the Q&A session. This webinar is being recorded, so at the end, you'll receive a recording link within a day or two afterwards so that you can download and watch anything that you happen to miss. So with that, let's get started. And I'd like to introduce the folks from AEI. Jeremy, would you like to introduce yourself?
Sure. Again, my name is Jeremy McKee. I'm in our Chapel Hill, North Carolina office. I'm a mechanical systems designer working in our energy and utilities group. We do a lot of chill water, steam, cogen projects, site distribution. Been with Facility Engineers for 7 years and been working with Revit for 6 of those years. Have approximately 50 plus scans with the DPI-8 scanner and have done 10, maybe a little over 10 point cloud conversions from EdgeWise to Revit.
Excellent, excellent. That's some great experience, Jeremy. Ifeanyi Nzewi, did I get your name right?
Yeah, you did.
Awesome, awesome. Can you give us a quick introduction to yourself?
Sure. Hi, so I'm Ifeanyi in the San Francisco office for affiliate engineers. My background originally was in architecture, but doing BIM now. I've been working in the BIM PDC industry for over 6 years. 3 of those years have been with AEI in San Francisco. Had a lot of experience with laser scanning and point cloud conversion. We used to do it the old way. Bring the point clouds into Revit and trace over it. So EdgeWise has been really a breath of fresh air and a big time saver. Had some good experience doing all of that and also using the DPI scanner. Had not as much experience with it as Jeremy has, but yeah, we've been collaborating a lot, and it's been a great tool.
Excellent, excellent. Thank you. And then on the DotProduct side, we've got Tom Greaves with us. Tom, can you give us a brief bio?
Sure. Welcome, everyone. It's good to be back with, I know some of you from the registration list. So a very long time ago, I was an engineer. I logged oil wells in the Middle East for Schlumberger. Lived in nice places like Abu Dhabi and Kuwait and Oman. Roll the clock forward. My wife and I started SparPoint in 2003, and we built a conference business singularly focused on 3D laser scanning. So I've been around 3D for most of my career, and I joined DotProduct 3 years ago to head up sales, marketing, and customer support. So I'm going to be doing the live demo in just a few minutes. If you hear some nervousness in my voice, it's because we're going to be doing something that most people get advised not to do, which is a live streaming demo. But we're really looking forward to showing it.
Yes, yes, we are. Yeah, we were joking. We've gone over, we've rehearsed this a handful of times over the last couple of days, and never without a hitch. So I'm sure we're going to have some sort of hiccup, but we'll make it through it, and it'll be fun. My name's Kevin Williams. I'm the chief scientist at ClearEdge 3D, and my background is in automated feature extraction, computer vision types of technologies, a lot of just point cloud analysis and trying to automate the processes that the human brain does so well, but computers are so difficult to make do. So that's kind of my background and my my passion. So with that, let's get started with just a real quick overview of what we're going to be doing. Agenda-wise, I'm going to be passing over the screen to Tom Greaves in just a minute here, and he's going to do a live scan of an environment inside his office. Some pipes and a little bit of ducting. And then he's going to email the file once he captures it. He'll email it to Justin Domer in actually not in our office, but in his home office. He will be processing that live using EdgeWise. And while he is doing that, then we're going to talk about the case study and a real life use of this technology with our friends over at AEI. We thought rather than watching a progress bar for 5 or 10 minutes, we'd do something a little more productive and let these guys talk about how this is used in the real world. And then finally, we'll take that, we'll switch over, we'll see how Justin is doing and check on his progress and watch him finish out the model and hopefully go all the way through and export to Revit. And during that time, we'll take the Q&A, and we can just kind of watch him finishing out the model in the background while we do the Q&A. So with that, let me switch over the screen to Tom Greaves. There you go, Tom. You should have control. Excellent. I see your screen.
Okay, great. Okay, so what we have here, I've got our handheld scanner mounted on the end of a 6-foot pole. And the tablet, so the scanner's up in the air. You can see some piping and duct work. Just show you what we're going to scan there. And I've got the tablet at eye level. So let me get started here. The first thing I'm going to do is just back up a second because I want to get a little bit of the carpet and actually want to get the back of Chris's head. Okay, there we go.
Chris is our movie star.
Yeah, okay. So I'm walking around our office. We're capturing pipes and ducting. And as I move closer to the piping, the yellow turns to green. So this is a real-time feedback about the quality of the data we're collecting. Often yellow is perfectly adequate, but for specific areas of interest, we'll try and get it green. And our scanner is stitching this data together live, and it warns me if I'm moving too quickly. It does that if it's struggling to relocalize. There, I've got some nice ducting. You notice that it lost tracking momentarily. It can recover from those situations quite readily. That's normal. And I'm moving around here to another part of the scene. I'm actually going to do a 180 and get back to this area and get that piping from the other side. Okay, so we got pretty good coverage on it now. And I'm not representing this as the workflow that you would use if you were going to replace all this piping. It's just intended to be representative. Okay, so I think what we're going to do is finish the scan part there. And the first thing the software does is it makes a backup copy of the data, so we can always recover to this point. And we have a quick look, and we can see that we've captured some pretty good data. And then the next thing I'm going to do is run an optimization routine. We don't have any targets, so I'm just going to use the targetless workflow here. And what we're doing here is aligning the frames of 3D data that we've collected in real time and taking another pass through them and tightening up the alignment. We're also leveling the colors in the scene from frame to frame, and we're eliminating redundant points. Okay, so there we have it. Then the next thing I'm going to do is set up a coordinate system, because we want this data to be passed off to Justin in a reasonable orientation. Right now, the coordinate system of the data is the z-axis is pointing away from the camera, and x is going to my right, and y is going down. And most designers I know like to have at least z up, so we're going to do that first. I'm just going to pick a point in the scene here, and we've set z up, and I'm going to make x. I could just as easily do y, come out of the wall, and there we have a reasonable data set. Okay, so we've optimized the data, and we've got a coordinate system. So the next thing we're going to do is save it. And this is going to be EdgeWise webinar live. Okay, continue, and we're going to save it in that coordinate system. So this is all being done on a very modestly priced tablet. The tablet is actually doing two things today. It's doing all the scanning job, but it's also a presenter in this webinar. So it's got double duty. I'm just astonished that a very modestly priced computer like this can do both of those things at once. And so then what we do is I'm going to email that file to Justin. So I select the email button, and there's the file, and we're going to send it to Justin.Dahmer. And just for fun, I'm going to email it to Kevin also, CC him on the data. There we go. And this is going to be subject line, webinar, demo, data. So the idea here that I'm showing, it's a very small file, 5.6 megabytes. Typically our files are, under 20 megabytes. A very large one might be 30 or 35 megabytes. But what I wanted to show here is that the small file footprint lets you send the data from the field to the office. And if someone in the office says, gee, that's not complete enough, you get to find out before the person leaves the field. That's huge, we think. We have customers that have some senior eyes looking at the data in the office, reviewing it before the field crew leaves. It's a way of increasing the productivity of those senior eyes because they get to review multiple crews' data. So all of this is enabled by having a data collection system that works on a mobile device, and then being able to send the data over a reasonable Wi-Fi or cellular network. So I'm going to press send, and then Kevin, you might want to switch the presenter to Justin so we can see that data come in.
All right, I just did that.
All right, I just hit the send button.
Justin, are you able to
Yep,
share
can you
your
guys see my screen all right?
Yes, yes, I can see your screen now.
Okay. Great.
So now we'll see how long it takes to get across.
Yeah, this may be the longest part.
It could easily be.
Okay.
This could be the glitch we've been waiting for.
Yeah, we've been pretty quick today. It's apparently.
Okay, I'm going to try sending it from another application. Shouldn't make any difference, but.
Kevin, have you received it?
That's a good question. No, I have not. Yes, I just did. I just did.
Okay. Yep, just got it.
All right, perfect. We're back on.
Okay.
Okie dokie. So I have a file here that we just created. It's a DotProduct file. I'm going to go ahead and save it to my computer. It's a DP file. Now that I've saved it, I'm going to go to EdgeWise, and I'm going to go to Process Scans. I'm going to select the file. And this is the same process for any file type that we work with. And hit Open, and select what I would like to start. So I want to make a database and a pipe file. Adjust the settings a little bit. And then I'm going to hit Go. And then once we go, it's going to go do its thing. So it should take a little bit under 10 minutes. And I will pass it off to Kevin, so we can about this process, and we'll get back as soon as it's done.
All right, perfect. Thank you, Justin. Okay, so you should be seeing my screen now, which talks about affiliated engineers. And if Yanni and Jeremy, do you guys want to take it from here?
Sure, we can do that. Hello, can you hear me?
Yes, I can hear you loud and clear. And I'm actually going to give the mouse control to Jeremy here.
All right.
But go ahead, if Yanni.
Okay. So we're from Affiliated Engineers. I'm in the San Francisco office. Jeremy is in Chapel Hill, North Carolina office. We're a large company. Have a lot of offices spread across the United States, have presence in the UK. Over 600 employees, go through a number of projects, have over 200 lead projects. Every year we tend to get a lot of as-built projects in which we do not have adequate documentation, so of the plans are not indicative of the changes that have been made over the years. So by the time we get to it, we see that what we have down on paper is outdated, and we don't have any CAD files or any other documentation that shows the changes that have been made. So it tends to be a frustrating process trying to get through. You can only take so many pictures when you're out on site, and that only works so well for converting into a smart Revit model. So we quickly recognize the advantages of laser scanning. That being said, sometimes on the type of projects that we have in which access to certain areas is not very straightforward, like a lot of pharmaceutical projects that we work on, having a third party come in with a terrestrial scanner to do the work for us takes a number of days for them to get badged. We have to pay for those days that they're working, regardless of if they're doing any work at all. So we figured that if we were going to be on site to record data or just to see what's going on and just document some of the things that we're seeing, it would be advantageous to have a handheld scanner, especially for smaller spaces as well, like chiller rooms and boiler rooms and such. So it's very, very straightforward to go in there with the product DPI and record the data, take a scan, bring that back into the office, and process it a lot quicker than taking lots of photographs and coming back and trying to figure out at what point were you when you took that picture, what exactly is the one picture you're looking at. So with that, I mean, we talked to Tom that you just heard from. You just saw do that live scan. He came into our office and did one with us, and we went ahead and purchased the DPI, and we've not looked back. And it's been a great tool for us in San Francisco and in North Carolina. We're having a lot of other offices show interest in doing that, and it has enhanced what we offer. So with that, I will pass it over to Jeremy and have him explain and go through the process of some of the projects that we've done.
Thanks, Stefani. The case study we're going to go over today is of a mechanical room, a local client. It's here in Chapel Hill, North Carolina. And the current as-built that we were given were really inadequate. When you compare the drawings to some photographs that we were able to get during kickoff meetings, things like that, you can tell that there have been several renovations, typically small things, but it was enough of the small instances where it would have caused major issues out in the field. So we really needed proper as-built documentation for coordination for the renovation that we're going to do. We're going to be adding pumps, bypasses, control valves, instrumentation and controls, things like that. So it's really important for us to capture the entire space. The project consisted of 5 different mechanical rooms across campus and multiple buildings, with the average size of mechanical rooms being about 400 square feet. I believe the smallest one was 200, and the largest one, which is kind of, I guess, an outlier, if you will, was about 3,000 square feet worth of mechanical room space, which we did not scan all of it, just because we didn't need it. There's a lot of open space, so we really only scanned the area that we're going to be working in. And each of the rooms really posed their own unique challenges, but most of the rooms were very congested, limited to line of sight. In this particular room, pictured here, the ductwork, kind of in the center of the screen, was probably about maybe about 5, somewhere between 5 and 6 feet above the ground. So we literally had to get on our knees to scan some of the space. It was also about 12 to 18 inches from the wall, which gave a tight, narrow corridor, if you will, to see above any of the piping that was up there. With 20-foot high ceilings, it was very dark. So we also had to bring our own light kit to be able to get adequate lighting for the scanner to see. Then, as we got to each site, as part of our field collection workflow, we did a pre-scan walkthrough to help establish what was important to us to scan. The areas that we're going to be working, any major pieces of equipment, major isolation valves that we needed, things that were really important. And then we also discussed, well, what would be nice to get, or no, where are we going to be close to, so we can make sure to capture that area for coordination purposes. We also discussed a scan route and where we were going to start our scans from, a central location, so that we could pin the files together. And also discussing a scan route allowed us to say, well, we want from point A to point B to be in scan 1, point B to C in scan 2, and it really helped us out. And after we did all of our walkthrough and let's pre-scan everything, if you will, we'll start setting up our able tags based on the pre-scan walkthrough and where we wanted our pin locations to be. And we typically worked with a 2-person scan team. One person ran the scanner, while the second person watched the person who was scanning, make sure they weren't going to trip over any drain valves or bump into any valve stems or anything like that. And if the person scanning was in a nice environment where they didn't really need to be watched, the second person went around, collected equipment data, so valve tags, equipment tags, took any readings from pressure gauges or temperature gauges, things like that. And here in this slide, you can see pretty good representation of the congestion up above. In the foreground, we have 2 chill water pumps, a steam to hot water converter kind of in between the pumps in the background. And a lot of the chill water piping was being removed. So it was very important for us to get as much of the chill water piping collected as we could so we can get accurate takeoffs and pricing, things like that for the contractor. We're also trying to clean up the space as much as we could for the owner for any future renovations or whatever they needed for the space. Here's some more chill water piping. Again, you can see it's very congested. You can tell the routing wasn't quite thought out, maybe due to renovations or other things that may have been here in the space that are no longer here. For instance, the piping that drops down to the bottom of the screen is actually connected to a fairly new inline pump that was not documented on any of the as-built drawings. And after we were done with all of our capturing out in the field, came back to the office, we prefer to use the .dp files are native to the DPI-8 scanner. And they imported to EdgeWise great. And we extracted all the piping, ductwork, conduits through EdgeWise. We set it to run overnight just because of the time. It was very simple. It's a hands-off kind of application for the initial portions of it. And after we did our QA/QC within EdgeWise, we exported it to Revit. We also imported the native DP files into Recap just for simple viewing, so we can bring the point cloud into Revit easily. Just for some of the other engineers that all they needed was to look around in the space. Again, we brought the point cloud into Revit for further coordination for things like lighting, some of the instrumentation that hung off the piping, thermometers, things like that. We also had to go through and added our existing valves and equipment locations, coordinated. If we needed, which is not very often, we created custom families. Within Revit, we also, at this time, went through, put all the piping and ductwork and everything on the correct systems that they needed to be on. So our design team could go through and do their tagging and start the demolition and new work. Our final deliverable was a set of construction documents showing the demolition and new work for additional piping. We're adding a pump, control valves, controls and instrumentation. This very tight space. And here we have some screenshot of all the MEP systems within Revit. You can tell all the ductwork, some large ductwork, some smaller piping. We've gone through, added valves, put things on different systems, added some electrical panels. And here's some more isometrics with the building turned on but turned transparent. You can see in the left picture, we weren't doing any work in this particular space. However, we needed the piping there so that we can account for things being in there for coordination. When we start adding pumps, we didn't want to say, oh, well, we just stick it over here when there's other equipment and other piping there in the way. Also, our new tile locations in the right-hand screen. Valve, a couple of gate valves and a control valve. The scan enabled us to very accurately locate where we're tying on at. Our DPI to EdgeWise workflow to time savings, we estimate it to be about 60% time savings. It took us 2 people approximately 10 to 12 hours to survey all the rooms. It was about 90 hours total for processing, QA/QC, and the model setup. So most of that time was spent during the model setup, which included developing the architectural model, assigning the different systems to the MEP model, adding valve at their correct locations, getting any equipment that needed to show demolished or existing, finding it, getting it modeled, and getting that put into the Revit model. We estimated that the traditional time or the traditional method to survey everything was going out there with pen and paper and a tape measure and measuring your bottom of pipes and so far off this wall, so far off that wall. Probably would have taken about, again, 2 people, about 250 hours. So it really was a major time savings. Also, one of the things that some of our clients really like, that the initial portion of letting EdgeWise run, extract all the data, really is a hands-off kind of application. You set it, you go home for the day kind of thing. And some of the project tips and tricks that we learned throughout multiple projects are really taking the time to walk through the space prior to scanning, so you know what you want to scan, what's most important, what would be nice to scan. Also, trying to figure out how many scans you may need. And take your time scanning. Don't rush it. When we first started testing out the scanner, that was one of our problems. We were get so excited that we're ready to go. We found that we really need to slow down and take our time with it. And for darker areas, bring additional lighting. It really does make a difference in the scan quality. I've seen things on online forums where people have, it's a simple flashlight or light kits I believe you can get from DotProduct attached to the scanner. That's what we've used and has been very helpful. Also, if you're using any type of targeting, such as able tags, try your best to square up to the targets, so you don't get them from a steep angle and get straight on with the targets, and also whatever else you're trying to scan. It really allows the scan to be very accurate. Luke, here, Tom Greaves is going to take back over.
Excellent. Thank you. Thank you, Jeremy. Tom, you want to talk to just kind of give us a recap and a summary of the technology that you guys have built there. Tom Greaves? Chris Ahern, are you available? All right. Well, let me, you know what I'm going to do? I'm going to come back to these guys in just a little bit. It looks like this is actually our real glitch. So I'm going to move on to the next slide and talk just a little bit about EdgeWise, and hopefully we can get Tom back online here shortly and to just explain a little bit more of the details of the technology that they've got. All right, so just to I know most of the people on this webinar are familiar with EdgeWise. Just to give you a view into our next upcoming release, the next things that we intend to put into the application include a PDMS steel export capability, which we've had a number of people asking us for. We're also going to do our very first language pack, which will be German, which I'm quite excited about. And hopefully we'll move on from that quickly to, we also, Chinese I believe is next on the list, as well as Japanese. But for this fall time frame, we're hoping to get out the German language. Also T connections inside of Revit, which has been conspicuously missing for some time now. We expect to have that available and ready, and that'll make life a whole lot easier for the guys going into Revit. And then finally, we're excited about a direct DWG export. So that'll make us a lot more compatible across some of the more generic CAD modeling applications. So these are the upcoming improvements to the EdgeWise software. Tom Greaves, did I hear you get back online?
I managed to reconnect. I apologize. I hit the disconnect button instead of the unmute button. So,
okay. Well, let me
what
back
can I
up.
say?
Yeah, these things happen. That's fine. Let me back up and let you talk about the DPI-8 scanner.
Sure. I'm not going to read every bullet on this slide. What I would like to leave you with is first of all, thanks to Jeremy. That was an excellent use case that he described, and to Ifeani also. Much appreciated. The thing that we do, and we believe we do well, is the real-time field data capture. We can capture and allow our customers to review, to assess the quality of 3D data in the field. And we do this with a small footprint. One of the lessons that we learned along the way is that, at the heart of success is the downstream workflow. So once you capture the data, what happens next? And, so we've seen some very good examples of that today in this presentation. So we've spent a lot of effort to build out the workflows to get our data from the tablet into your engineering, design, and asset management tools. We'd welcome the chance to have a longer discussion with you about that in the future. Happy to do one of these web demos going forward for your organization. With that, I'm going to pass it back to Kevin. Thanks very much.
All right, thank you, Tom. So, all right, so that's the DotProduct side. In parallel with the improvements that we're building into the EdgeWise product, we're also working, I believe a number of you are probably aware, we're working on a new application called Verity, which is for construction validation. And the idea is that it compares a design model to ongoing laser scan data particularly on a construction site. That's what we're targeting initially. And so the idea is to figure out where there are discrepancies between what was supposed to be built and what's actually being built. The software is able to verify whether things are actually there or not, so you can tell if it's been installed or not. It automatically flags any out of tolerance work, and we're building it out as a very generic algorithm, so it works on anything, not just the traditional EdgeWise components like steel or piping, but it works on lighting, on walls, on windows, on anything that you can bring into a Navisworks project. You can analyze inside of Verity. In the future, not in the first release, but in the future, we will be able to adjust that design model in the end to whatever the point cloud says is actually built, so that you can end up with an actual as-built model of your conditions there. And initially we intend to release this as a product that's completely integrated with Navisworks. Very shortly thereafter, it will be integrated into Revit and Tekla as well, and probably some other applications. So just a real quick overview of what the software looks like at the present, and we're currently in beta with just a very small number of companies. We're trying to nail down the functionality, and we intend to have a more open beta in the future. But for right now, here's what the software looks like. It loads in a Navisworks design model, loads in a point cloud, and then analyzes it and gives you an element by element analysis. So you can see it's color-coded up the different pieces of steel in this case as to whether they're present or missing or out of tolerance, etc. And then we've got some fine detailed reporting in the actual Verity application, which is what you see on the left-hand side of this image. That's the Verity application. We've got a table that reports very precise deviations in the vertical, horizontal, and also if I were able to scroll the table over, it reports rotational values as well as object coordinate system values for any deviation. So you can see in the right-hand side, let me see if I can move my mouse here. Hopefully you're seeing my mouse. The right-hand side shows the Navisworks instance of what's happening. So you can see this beam here is quite a ways off from where it was actually installed in the point cloud. And that's what we're seeing over here in the Verity application as well. The purple element in the Verity side represents where the beam is supposed to be. The blue represents where the software actually detected it, and then it's calculating a deviation between those two. So we're doing some intelligent fitting and analysis based on the points in the vicinity of that of each element. So that's what is going on under the hood inside of Verity, and that's what we're working on in parallel with our updates to EdgeWise, and we hope to have a product out in the early part of 2017. So with that, those are some product updates. Let's switch over to Justin's screen and see how he's faring.
Sounds good.
There you go, Justin.
Okay. Hopefully that should be sharing in a second here.
Yeah, I can see your screen. Looks like all files
Okay.
processed successfully.
Yep, so we processed everything. It took under 10 minutes, so I was done a while ago. But at this point, now we can go ahead and actually set the modeling process. And so I'm just going to go ahead and jump into it, basically. Kind of take a look at what we got and what we extracted based off of the data that we just got. So from here, I'm pretty much just going to go through the general workflow and use the tools. Kevin, I know that we're going to do the QA. Are we going to be doing that first, or should I kind of go through the process and explain a little bit of what I'm going to be doing?
You know what? Give us like a 3 minutes in. Just walk through the basics of what you're doing here to create this final model.
Okay, gotcha. So the first thing is the QA process of just simply going through and taking a look at what we got, and also using our QA tools. So we've got some extractions here, but a lot of this we can do really quickly with our extraction tool. But we can take a look now using our inspection mode for some of the other stuff that we got. So we have our inspection tool. So with this, we can actually see the quality of the extractions and the points themselves. So we can see here just how things line up. So that's kind of what I'll just quickly do is jump through that. And based on what I see, it looks like stuff's pretty good. So not too worried about that, but that is kind of the normal workflow. And then from here, I'm pretty much just going to go and make a bunch of connections. So if stuff is not quite right, we can just delete it and edit it. But as far as regular extractions, it's really a process of drawing a quick box around it, double-clicking, and having it actually created by that. So we can go through here and do that. And I'm actually going to turn the clipping box on just to make it a little easier for this process. And we'll just go through and extract some stuff. So once I have things extracted, then I will do a connections. So I have an automated tool for actually connecting stuff. That's based on what I see here. we can use this process. We have our ducts already extracted somewhat there. So then I can go through and make connections. So I have a manual tool for connections, but I can also just hit our Easy Connect tool and just let that go and see if we can get some of it. This is a really small data set, so there's not a ton of stuff going on for like what we're actually going to be using. But you know, we can go through and do this process. So I think we ended up filling in, and there's some stuff that was in the clipping box that's blocked here, so we can't quite see some of it. But now I'm going to go through and just fill a lot of this in. So it looks like this needs to be connected, so we can fill that in. I need to extract some elements here, and so it's just kind of moving around and using the same tools and going. So pretty straightforward from this point on. Once I get pretty much the main sections actually filled in, then I'll go through and actually clean things up, and then I'll also give it a shot at getting it standardized, and then we'll throw it inside of Revit. So it should be pretty quick to go through that process.
Okay.
So we got
Okay. Perfect, Justin. So while Justin is doing that, let me jump to some of the questions that have been filtering in the meantime. And so we can just kind of watch Justin modeling here in the background, and I'm going to start fielding some of these questions. So the first question is for Tom. What was the scanning rate that you used in this demo?
So our device captures at 30 hertz, okay? And so 30 times a second we're capturing a frame of data. In the webinar, because we're sending this over a Wi-Fi link, you know, we're broadcasting the contents of the screen at the same time as we're capturing them. That slows down. It's probably only about 5 frames per second that you see, but the device itself is capturing 30 times a second. And so this drives how quickly you can walk through the scene. Have I answered that question to your satisfaction?
To my satisfaction, yes.
Okay. Okay.
Cool, thank you, Tom. This next question is for me. Does EdgeWise only process one DP file at a time? What if there are multiple DP files based on one coordinate system? The answer is no. The latest version of EdgeWise, we've improved the way that we handle DP files. We handle them directly and a lot more efficiently now. So we're able to, if you've got 5 appended DP files, you just load them all in, hit the go button, and it goes off and processes it. And if you've used EdgeWise with DotProduct in the past, you'll appreciate the new time savings. It's a whole lot faster. Next question is for you again, Tom. To send the data from the field, does a tablet need to have internet access?
There are 2 ways. One is if you have Wi-Fi access, you can send the data from the field. But actually, there are multiple ways. So certainly, if you have Wi-Fi access, that's a good way. You can also send it. You can set up an FTP link if you have Wi-Fi access. I have I set up a hotspot on my phone typically when I'm doing it. The other ways of getting the data from the field are to attach a thumb drive to the tablet. There's a special cable that comes with the device, and you just load the data onto a thumb drive or onto a micro SD card and transport it physically. But it's either either wireless Wi-Fi or physical transport of the data media.
Okay. This question was addressed to Tom, but I'll also open it up to Jeremy as well, because Jeremy, you've got a lot of experience in this. Can you scan the whole room in one time?
Typically, no. It took us multiple scans to get the rooms, but like Tom said, the speed that you can move through the rooms is very nice. So we only needed one site visit, but again, it took multiple scans.
Let me take a crack at that too, Kevin, if you don't mind. So the biggest room that I have ever done in a single scan, I was with our dealer in Microgeo in Italy in January, and we went into a gas pressure reduction station, and the room was 10 meters, so about 30 some odd feet by 5 meters, 15 some odd feet by about 4 meters, 12 feet high, a little bit more. And I was able to get that in a single scan, but I was hustling, and, to get around it, it was right at the limit of what we could do. I would make that the upper limit of what you could expect to be able to do in a single scan, and typically, you would want to capture spaces that are much smaller than that in more detail. But, so this does not replace, this handheld scanner does not replace a terrestrial laser scanner particularly for large spaces. Well, I wouldn't recommend it. If you need to get it all in one go. We can, of course, stitch together multiple data sets.
Okay. I was watching in a little bit of fascination Justin modeling here on the screen. He's got some areas with fairly sparse coverage and apparently some pretty intricate detail. So in a real world scenario, we could obviously capture a little bit more data on those areas and probably do a lot nicer job in terms of capturing actual reality in those instances. But don't worry too much about that, Justin. I think the point gets across. Next question is for Jeremy. How many targets did you use for the average mechanical room?
Average mechanical room. I really don't know. We didn't really count them. I would gotta guess I'd say 20 or so.
These are April tags, right?
Yes, correct. April tags.
Okay.
Correct, April tags. We try to get them every few feet, and on some of the rooms, on any flat surface that wasn't vibrating, duct work or whatever wouldn't do very well. We try to have a couple of them in every so often for optimization.
Okay. This is a question for you as well, Jeremy. What advantages, disadvantages did you find in using the DPI-8 versus a terrestrial scanner? And maybe a way to refine that question is when is it appropriate to use a longer range scanner versus the DPI-8? When do you use which?
I'd say depending on size and time. The DPI-8 allows us to get smaller spaces and to mobilize very quickly. The head engineer here can say, hey, I need you out in the field tomorrow. I go grab the scanner, make sure the batteries are charged, and out in the field tomorrow. With the larger terrestrial scanners, we typically sub that out just from a cost perspective of acquiring one of those larger, more expensive scanners. The DPI-8 was a great price point for us to get into scanning. The largest space that we have scanned to date was actually this week. It was about 3,800 square feet. However, we used hard targeting for that. We did not use April tags, and that took about 2 days.
Okay.
I can get in on that as well. I think that one big advantage that the DPI has is that while you're scanning, or just after you're done scanning, and like Tom was saying, you can send this information back to the office over Wi-Fi. And right in the office, if there's something or an area that one feels that more data needs to be collected on, or something that's not very clear, they can let you know right away. And Jeremy's out there and he sends that out to the office, and they can say, hey, can you go behind the chiller and try and get some of these other pumps and so on. And you can do that while you're there versus having to go back out with a terrestrial scan, and another day that, you'd have to schedule to make sure facility management can let you in and so on. It saves a lot of time on that as well, and it's a lot easier to get really harder and smaller spaces, areas where you might not be able to squeeze into with a terrestrial scanner. You can stand on ladders with this. You can, go behind columns. It's a lot easier to access tight spaces with a handheld.
Hey, Kevin, if I could jump in on that too. We have been developing workflows to combine terrestrial data with handheld data. Probably the most sophisticated and advanced one is with ZNF. We can transmit our data. We set up an access point, set up the ZNF 5010X as an access point. We send our data to it, and it's registered in the field on a Microsoft Surface Pro tablet right then and there. So we get to combine the ZNF data with the handheld data right away. Another sophisticated workflow is to do it in the office with applications like Cyclone from Leica or RealWorks, where we can combine the terrestrial data with the handheld data. So we capture the big areas with the terrestrial scanner and fill in the shadowed, occluded, missing areas with the handheld data. And that's a well-established workflow, and we have a number of customers running with that.
Yeah, absolutely. I know a number of people trying to do exactly that, using that exact workflow. That's a great point. Justin, do you want to just, we're actually bumping up against the hour. Do you want to go ahead and clean that and export it to Revit? Just so we can see what the final Revit model will look like. And in the meantime, let me ask all of you guys, what are the light, color, distance conditions of the room to get a point cloud with the quality to get the model into EdgeWise? So what are your recommendations on lighting and distances to kind of optimize that scanning process?
I'm happy to jump in on that, Kevin. What we recommend. The sweet spot for distances is to be 1 to 2 meters or 3 to 6 feet away from whatever it is you're looking at. That's a good compromise between getting the level of detail that you need and allowing the device to track successfully. As far as lighting, I would say that we get the best results in the conditions that are lit that would be appropriate for a photograph, okay? Or a video camera. And if that lighting is absent, then we strongly recommend using our onboard light kit. The other end of the lighting question, though, is daylight. Our device does not work in direct sunlight. Sunlight washes out the signal, and we don't recommend it for bright sunlight. We can scan outside, but the sun has to be low on the horizon, so early in the morning, late in the afternoon, or on an overcast day.
Okay, makes sense. Another question is, what is the largest area in square feet that you could scan for an area that has this type of complexity? So mechanical room level complexity. What's kind of what's the outside limits of what you would recommend?
Again, for the case study that we looked at, the average mechanical room size was about 400 square feet. I guess using April tags, it doesn't seem to be so much of a square footage, but how many scans do you need? There's a particular workflow for using that, but if you need to, I'd say 500 square feet. Seems from our experience, anything after that, you would really need to go to a hard targeting type method.
Yeah, let me jump in on that a little bit. If you use survey control or hard targeting, in other words, if you have some well-defined, well-surveyed control points, you can extend the scan, in the same way that you would extend a terrestrial laser scan. The trade-off comes, if the geometry is very dense and congested, you're inside a semiconductor fabrication facility, for example, then that effort may be justified. If it's an open parking garage, it might make much more sense to use a terrestrial laser scanner. So the question, I believe, was specifically about mechanical rooms, and I would just punt that back a little bit by saying it depends on the complexity of the space. We have done some very large spaces when we have survey control.
Okay, fantastic. Well, just looking at the screen here, looks like everything imported into Revit just fine. It looks like we've got a pretty good representation of everything that you scanned there, Tom. Very cool. Thank you, Justin, for doing the modeling and getting all those details in there. This looks great.
Yeah, no problem.
All right. Well, we are 3 minutes past the hour, so we're overdue. I want to thank everybody, all the panelists. It actually went off relatively, really quite well. Few minor hitches. I'm totally impressed. Thank you guys very much, and thank you the audience for watching this. I think it was a lot of fun to pull all this together and kind of show this whole workflow. It's some really cool technology the guys at DotProduct have built, and it's cool to see it being used like this. So thank everybody. We will see you next time on the next webinar. Bye, guys.
Thank you.
Thank you.